Alright, the practice 1.1.3, assessing normality. Okay, so we've got 3 histograms here, and we're going to ask 3 questions about them. So number 1, which histogram, if any, are normal or approximately normal? So remember that normal is going to have that bell curve shape, which, if we do these, this one looks like a box, so definitely not that one. This one goes down. And this one, we don't have that bell curve either. Kind of together they would make it. But if we look at histogram A, we can see that it's kind of approximately doing that. The mean has the highest points near it, and then it tapers out evenly as we go out. So that would be histogram A. Okay, number 2, which histograms, if any, are skewed to the right? Now, that's definitely not skewed. That's definitely not skewed. So it's either B or D. Now, looking at these, remember that the way that it's going to, the curve goes to, that's what we say, skewed. So histogram B would be skewed to the left. Histogram D would be skewed to the right. I know that seems opposite of the way you want to think about it, but that's how they determine it. So it would be histogram B. Then number 3, which histograms, if any, have a mean that is less than the median? Okay, so remember the median is if we line all the numbers up, it's the one exactly in the middle. The mean is the average. Okay, so looking at these, we can try to determine which one would have a mean that is less than the median. Okay, it's definitely not D because there's the same amount in each one, so the median, the mean would probably be the same. Same with histogram A. That's one of the rules with being a normal bell curve, is that your mean and your median would be the same. So it's either going to be B or D, once again. So looking at this, okay, the higher it is, the more numbers would be up here, right? Okay, and here we've got some numbers pulling it down. So averaging these ones would probably be, the average would be further down than the median. The median would probably end up being higher because these lower numbers would pull down the mean while not affecting the median as much. Oh, I mislabeled this one, didn't I? That was what was throwing me off. So then this one would be histogram B. Okay. Alright, now let's take a look. The table below lists the positions and weekly salaries for the 60 employees of the Down in the Dirt Landscaping Company. Alright, so we've got these positions, their weekly salary. Okay, identify any outliers. So remember, an outlier is something that is far off. So if we're looking at the histograms, like how this piece is clear off, that would be an outlier. Okay. So looking at these, we have 320, 480, 490, 500, 600, and then we jump up to 1500. So obviously this one is going to be your outlier. Okay. So if we think about it, you know, being the head of the company, obviously you're going to make more, and usually a lot more. So that would explain why it's clear out there. You know, should we eliminate it? Well, it depends on what we want to talk about. Are we talking about all the employees, or are we talking about, you know, a certain type of employee? It would be tough to make the case that you're going to remove him because that's only one person. And then, do you remove the supervisors? Do you do just the people that are, you know, out working? Do the supervisors go out? Are they directly working with them? You know, what's the case here as to how or why you could remove that? That's what you've got to think about and how that would affect your data. Okay, so we know that's the company president. That's the outlier. And then whether you should keep it or not, it kind of depends on where you're going with it. Okay. So, what percent of the employees at Down in the Dirt make more than the mean salary? So we'd need to find the mean, wouldn't we? Okay. which we can simply find by adding them all together. And then dividing by how many there are, which there's 16, right? So we end up with the mean salary of $543.75. Okay. So what percent of the employees at Down in the Dirt make more than that? Well, that's the supervisors and the company president. So that's 1, 2, 3, 4. 4 out of 16. So, 4 divided by 16 would give us 0.25. So 25% make more. Now, is the normal distribution an appropriate model for the salaries? Well, with this company president, I think it's pretty obvious that it's not going to be, because that's going to mess up the mean. If we were to figure out, just to show you, if we were to take away his part of it for just the mean alone, the mean would then be 480. That's almost $100 difference if that one person brings it to. So, because of that, it's going to look like this. So it's going to be skewed to the right, so it's not, because that company president skews it to the right. Alright, so let's use the next one. Mike's job is to analyze food products for nutritional value. Recently, Mike determined the grams of sugar in samples of 12-ounce soft drinks sold at a local convenience store. The sugar content of 30 cans of soft drinks is shown in the following table. Alright, so grams of sugar per can. What percent of cans have a sugar content within one standard deviation of the mean? Okay, so we're going to need to find our mean. Okay, we're going to need to find the standard deviation, and then we'll be able to use that to create our bell curve and do that stuff, okay? So, let's do that. So, I'm going to do that on my computer or calculator, and then I'll give you the answers. So the mean, when I round, is 26.9. Since they round to the 10th, we'll round to the 10th. And my standard deviation would be probably 1.5. Let me just double check it if I round my other numbers. Yeah, that doesn't change things. So, if we're thinking about that bell curve, right, our mean would be 26.9. And one standard deviation away, we'd have to add and subtract. So 26.9 plus 1.5 would give us 28.4. Okay, two standard deviations plus 1.5 would be 29.9, and then 31.4. Going the opposite way, 26.9 minus 1.5 would give me 25.4. Subtracting it again would be 23.9, and then a third standard deviation, 22.4. Okay, so now it says percent of cans within one standard deviation, then 8 is within 2, and 9 within 3 standard deviations of the mean. Okay, so let's take a look at these. So the one standard deviation would be 25.4 to 28.4. Okay, so it'd be all of those ones. Not the 24s. Not the 30. Okay, so it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So 21 over 30 would give us our percent, which is 0.7 or 70%, which is pretty close to 68. We say it should be 68%, but sometimes with the numbers it doesn't always come exactly to that. Okay, so 70% is what we've got. Now the next one wants to know within 2 standard deviations. So we'd extend that out, right? So we use all those ones that we already have, plus some. So we're going to 23.9 and 29.9. Okay, so that would include this one, these two, this one, and these two. So all but 2, right? So it would be 28 over 30, which would be 0.9333, so 93.3%, which is pretty close to the 95. Okay, and then the last one is 3 standard deviations, which that would take us to 31 and 22, so that would include the last 2, so that's going to be 30 over 30 or 100%. Because this doesn't keep going, essentially that's why our percents are slightly different than those rules. Because we would say that this is 68%, which is pretty close, 95%, and 99.7%, which are pretty close on both. Alright, so the last one, Mike used his SOTA data to create a normal probability plot, okay, which basically is taking those plots and the closer you are to this line, the closer it is to a normal plot, okay. So is it reasonable to assume that the sugar content in the population from which these cans were selected is normally distributed? Yeah. Because looking at this plot, the numbers are so close to the line, okay, that means that yes, it's going to be normally distributed. Okay, if we made a histogram of that, we'd be able to see that curve right there.